What if someone totally didn't do the homework and they're just going to look at the video and be like, and copy it down? If they didn't do the homework, what weren't they able to do? The Google Classroom. So they already have it late, number one. And number two, just copying down is never a way to learn. But why would it be helpful to have this in the recording? In case you're absent, you can grade your homework just like we did in class, because you get points for grading your homework and having it all graded and corrected by the test day. So you can grade if you're ever absent, or if for any reason you didn't get to finish an assignment, you don't have to stress about just writing everything down, having no clue what was going on. You can be like, I got stuck at this number, get your question answered, and then go back and grade once you're able to, with integrity, attempt. Does that make sense? Cool. Sorry, a lot of logistics, I know, because we're doing first times. As you guys grade, hopefully you're just putting a quick little line through if it was wrong, and then writing the correct answer. So number 8, you can already see. Number 14, you guys have hopefully already checked, and you saw that it was quadrants 1 or 3 that we talked about yesterday. Number 44, doing the transformations to the points. I heard someone had a question on, was it 54 or 58? 54? Okay, and then 58, there was a typo actually, so let's look at both really quickly. So on number 54, you were given the question, what is the y-coordinate of any point on the x-axis? What is the x-coordinate of any point on the y-axis? They could have also said, what do you make y whenever you have a x-intercept, and what do you make x whenever you have a y-intercept? It's technically the same question, but you might not have realized it was the same question, and some of you are like, oh, I don't remember how to do that. So just thinking really quickly, can anyone explain why the answer is really just make that one 0 and then make this one 0? Well, that's true. Both the axes do meet at the origin. So one way of thinking about it is if you haven't gone anywhere on the x, then the x is 0. And if you haven't gone anywhere on the y, then the y is 0. That does kind of help you out with the location. But it's not asking for the point 0, 0. It's asking for the y's are always 0 on the x-axis. How come? If you're on the x, have you gone anywhere on the y? You haven't gone positive? You haven't gone negative? Well, what's in between positives and negatives? Got it. If you're on the x-axis, right? Oh, I just did that one. I apologize. If you're on the y-axis, have you gone anywhere on the x? Have you gone positive? No. Have you gone negative? Nope. What's in between? 0. So it was just having you think about if I'm on the x, oh, y is 0. If I'm on the y, oh, x is 0. Thinking about intercepts. Does that make sense? 58. Why was he weird? Whose book did not have in pen letter A changed? Whose book did not have a student actually cross off letter A in their book and write something else? Okay, so anyone's book whose that had not been corrected. I try to have students do it every year, but for some reason, that don't ever get corrected. There is a typo. See, I was telling you, it got released a little too quickly. There is a typo for letter A. But I'm not going to explain what the typo is quite yet. Some of you guys, someone did change it, and that's perfect. But if someone didn't, you can get out right now a color pen, black or blue. You can get out a color pen, and I'm going to have you correct it in just a second. But first of all, let's see why there's a typo, because some of you didn't even know what the question was talking about. Can anyone tell me, from the point being in the second quadrant, what are 2 clues, 1 clue about x and 1 clue about y that we know? We don't know the number, but what do we know? Go ahead, Tony. Good. The x is going to be negative, and the y is going to be positive. Can't be 0 because it's not on the axes like we just talked about. The x is negative because you had to move left on the x-axis, and the y is positive because you had to move up. So we don't know what the number is in any way, shape, or form, but I do know x is negative, y is positive. If you guys are thinking about, let's get the year going form, didn't I have you talk about how your brain works just a little bit as far as like how you learn and things like that? Okay. Some of you know that you're better at concrete things like geometry. You liked it when you could see the pictures and you could visualize it. Maybe you didn't like the proving thing, but like you liked being able to see it and manipulate it, visualize. Some of you guys like algebra more. You like the abstract, you like the puzzles, you like putting things together. If you like the abstract, maybe we could just stop here and say x negative, y positive and use that. But if you like concrete things, things that you can see, and abstract gets kind of hard, maybe you could just make up a point and be like, this is really hard for me. He's a negative number, he's a positive number. Let me just pretend that he's something like, I don't know, -1, +2. You could pretend. Is it that point? No. But is it a negative and a positive? Yes. So you could have also pretended that you knew what the point was, at least approximately. -1, sure. And then you could have used it in all of these little different transformations to see where it would go. For instance, if we were to plug it into letter A right away, okay? If we were to plug into letter A, why does letter A not match with any of the ones up above? What quadrant would letter A need to be in?
1.
You would think 1 if it was a positive and a positive, but he's not positive. He's a negative. So he would need to be in quadrant. Wouldn't he just be the same thing? Is there any graph that shows the same thing? He's in the second quadrant, but isn't he like a totally different location? So this guy doesn't have a match. So what we need to do is figure out, okay, which of these do match? And then once we figure out which of them do match, what's the graph that was supposed to match to? And then we'll figure it out from there. Okay? I know some of you already have it written in your book. That's perfect. Just for those that didn't, we're kind of problem solving, exploring a little bit. So let's talk about B. What's going to be true about the new x after you multiply the old x by -2? You can either think a negative number times -2 or -1 times -2. What's the sign of the new x? Positive. And not only positive, but it's also double the distance. So instead of going left a little, it's going to go right a lot more. Not a lot more, but double. And then what's still going to be true about the y? Still going to be a positive. So if I have a positive x that goes even further than that one did, and a positive y, what quadrant should I be in? So what's the only proper answer or match for letter B? Yep, he's quadrant 1, and he's over a little bit more than the other one was. How about letter C? What do we know is going to remain true about the x? But what's going to happen with the y? So it's still going to be negative. It's still going to be in the second quadrant, but it's not going to be as high. The only proper match with that is going to be 4. Good? Because it's still a negative up as high. And then this one. Check it. What's the new sign of the x now? Good. A negative times a negative will be a positive. And then what's true with the y? Negative. A positive times a negative. So you're going to have a positive x to the right. What quadrant will that put me in? The match is number 1, but what quadrant am I in if I'm down here? Good. So the match is 1. So who haven't I used? What should they have put? Now, if your book wasn't changed, now with a colored pen, you can go ahead, or with even a black pen, you can put a line through the old one and now put the new one. What would have put me into, this is the one I'm trying to match it to, into the third quadrant? I needed the y to be negative as well as the x, but the x already was. So the x needs to stay the same, and the y needed to be negative. See the typo? But as soon as you have the x being negative and the y changing to be negative, now you can make that proper match to 2. Is that cool? Okay. Sorry about the typo, but it did make you think. Some of you were like, the whole problem made me think, but some of you were like, yeah, that tripped me up just a little bit. All right. Any other questions on homework real quick? Odds or evens? Okay. Odds, you should have been able to check in the back of your book. Evens, we just checked all together, and you were able to ask questions on both. I know, still a lot of logistical things. However, did anybody read in your homework, and I think it was right here at the very top of the page, did anybody read at the very beginning of the assignment what this says? Just did. What? If you have any friends that have taken HPrecalc, they've probably already told you about calcchat.com. What is calcchat.com? It's a place that you want to bookmark. I'm showing it to you because it's like Slader but better because it's specifically for your book and it's not usually wrong. Slader, I do not usually agree with how someone does the problem. Doesn't mean it's always wrong, but I don't necessarily agree with it. We want to go to Precal with limits. So that's not it. Am I in the wrong edition? Third edition. There we go. You want the yellow book, long story short. And once you do the yellow book, I would actually wait and I would bookmark until you get to our book. You could have done chapter 1, section 1, exercise. Give me an odd that you guys had for homework. Sweet. Go. Oh, hey. Doesn't just say quadrant 2, it also says, well, I think that was exactly what the question said, so it didn't really help. Was there anything that needed a little bit of work, maybe farther in the homework?
31.
Perfect. Thanks. Oh, hey. Not just the answer, but some work that goes along with it. Well, that's kind of cool. Is that all there is in this? Nope. There is like an online tutor that's there every school day from 4 p.m. to 12 a.m. that's willing to chat with you about your specific book and your specific question. That's pretty cool. Yeah? Odd-numbered exercises only, though. Quick heads up. There also are, I have to go back up here, though, sorry. If you go back. There's an app that makes it a little bit easier for you guys to be able to access. Oh, I can't find it right this second. There are also videos. I think I needed to go back to where I was just a second ago. But there are also videos that you guys can sometimes access that gives you like little tutorials about how to solve. Can't find it right this second. But why do I talk about cheating? Because in this day and age, it is so easy to cheat if you get stuck on a problem, or it's so easy to shortcut. But why do I still show you CalcChat and make sure you know about CalcChat, especially for the odd-numbered exercises? If you get stuck, you can keep going. That's the joy of having so much at your fingertips. You can be like, how did I get stuck? What did I do wrong? How? And then you can go look at the odds at least. And if you're stuck on an even, go look at, doesn't almost every even have an odd that's like it? You can go look at the odd, try to figure out what the process is, apply it to the even, or on an odd, you can go and, now, don't just necessarily erase all your work and write what they did, because to be honest, I show sometimes, I think, easier ways than the odds are worked out on CalcChat. It's easier than maybe the person did it in the answer key, so beware. And sometimes CalcChat is wrong. Remember I said this book was released a little too early. It's a great book, just there are some mistakes in it. So you can't always just take what they say as, what should I say, gospel truth? Why do I use that? Because I believe the gospel is completely true, and so a lot of things have some truth to them, but anyway. So don't just take CalcChat as right and always right, and I can bank my life and my homework grade and my understanding of pre-cal on it. Don't do that. But you can access it and say, can I find my mistake on my own? Because that process of knowing you got it wrong and then you having to go search and not just having the answer thrown at you or not just having someone write it all out, another solution some way, shape, or form. But once again, it's not always shown step by step, and so hopefully it'll be enough information to usually let you see your mistake. Okay? All right, any questions on grading homework, doing homework, accessing CalcChat for homework? We already did Google Classroom. Kyle?
We're going to section 1.2. Do you want us to start on another page?
Yes, please. Yes, please. So same thing as the notes, start on a new side. Doesn't have to be a new page, but a new side. Yeah. At the very top. And then still do your same heading, because that way when you take a picture, I should be able to see your name, see your period, and then see the full assignment. Robert. Okay. So we're going to start notes without you, okay? Okay. Good? Cool. And then writing directions and problems, we'll see tomorrow how you guys did, whether or not you have any questions. Let's get into the notes. Homework spirals, you can go ahead and put away. Google Classroom, turning in the assignment and pictures of the assignment is me seeing that you had it as attempted as possible. Doesn't mean it's always perfect, but you've really worked on it and you've attempted the whole thing as best you possibly can as an honors pre-cal kid that goes above and beyond. But then by test day, you should have each of the assignments graded and corrected, which you can't always do in class. You can always grade in class, but you can't always figure out the corrections in class. All right, here we go, section 1.2. So I'm still getting the hang of things. Do we have till 45, right? Okay. I don't know why it threw me off. Oh, chapel day was yesterday. That's okay, solution points. If a point is a solution, well, hold on, let's come down to the example, then we'll try to fill that in. How can we show or how can we check that this point is a solution to that equation? It's not meant to be hard. Yeah, go ahead. Good. For this equation to be valid, or this point to be valid, I should be able to plug in the y, right? And plug in the, remember, always plug in an x in parentheses. So wherever the x is, it's marking a location. We'll talk more about that with function notation. But always plug in an x with parentheses wherever he is. Guys, does 4 equal 7 minus 3? So is this a solution? Yes, right? So what kind of statement should result when you plug a point in if it truly is a solution? Good, a true statement. If it's a false statement, it's not a solution. Easy as that. And if you're solving a system of equations with elimination or substitution, don't worry, that's coming in the future. But if you're solving a system of equations and you ever get a false statement, maybe there is no possible solution. If you get a true statement, well, that one's a little trickier. Oh dear. Let me bring this down. Sketching graphs. Point plotting. Not what I meant to do. Sketching graphs. My projector's all funny this year. Not that it's bad. I just need to bring everything down a little bit. There you go. Back in the olden days, Algebra 1 days, maybe before, but for most of us, Algebra 1 days. You didn't know what a variable was like. You didn't know what an absolute value was like. You didn't even know what a line looks like, to some extent, as far as an equation. So in the olden days, if you needed to sketch a graph, well, worst comes to worst, you make a... You can't start with a graph, start with a table. In the olden days, you would start with a table. Now, typically, yes. Typically, tables, you do x and y's, and then you go ahead and fill in. Why is this annoying if you're doing homework? Because all of a sudden, you've just used up all sorts of different lines, right? So it might be easier, just from experience, in calculus where sometimes tables are nasty and you have to write it out. Even though the vertically oriented tables are good, I would probably suggest, as far as just being able to keep it nice and neat and in your homework as far as what lines you're using, I would probably go a horizontal table. Just a quick heads up. This is technically a last resort. You shouldn't start with a table. At least by the end of pre-cal, you shouldn't be starting with a table. Functions, at least. But it still is a super valid strategy if worst comes to worst and you have no idea what a function looks like. You can always go back to a table. Now, should you always necessarily do the whole little Algebra 1 thing of, do you guys know what I'm talking about? What Algebra 1 numbers do you almost always use?
0.
Oh, right? Isn't that usually what you guys use?
0.
That's what I used when I taught Algebra 1 like 2 years ago. -2, -1, 0, 1, 2. That's almost always what you use, because it's a line, it's easy, get a few. Or it's a parabola, it's easy, get a few. But once you start shifting and translating, and Algebra 2 right now is doing all the transformations, reflections and stretching and shrinking, and anyway, it's good stuff. We'll get there too to review it. So you might the same, maybe like your math experience has made it so that, for instance, you wouldn't necessarily go plugging in a 0. Why wouldn't you plug in a 0 to this guy? It's going to be a square root of a negative number, which will be complex, right? Don't plug in a 1. Don't plug in a 2. Maybe start with a 3 because that's a bit easier, right? So maybe your math knowledge will kind of dictate how you make a table, but still totally a good strategy. Out of all of these ones, though, just up to this point, what you've learned, you've been through Algebra 2, which one should you be able to do with that? Yeah, bottom right. You should be able to do y equals mx plus b, right? M is slope, b is y-intercept. We'll review a little bit, but you should be fine. What else should you be able to do? Yeah, you should be able to do the first one. Another y equals mx plus b. Some of you might need to remember the over 1, and that's going to be your run, et cetera, et cetera. But for the most part, you should be good. Anything else we can cross out? It's okay for both of these to be tricky at this point. We're going to review tricky quadratics. This isn't a normal basic quadratic that's been shifted down or reflected. This guy makes everything a bit more complicated, right? Hopefully by the end of chapter 1 and chapter 2, you'll be fine graphing him and him. But I would say this is the best candidate for using a table, just because this one is a square root, but it's a square root of an x squared. It's more complicated. There's a lot of stuff going on. This, a lot of you guys were like, it's a quadratic. I think I should be able to know something, right? But it's valid if you were like, can I use a table on him too? Yeah, technically, for right now. So let's talk about some different graphing strategies. Yes, the tables are good, but you've learned a lot. And in what you've learned, you've been able to, or you are able to, identify some graph clues. You should be able to identify some graph clues. That will help you out so that you don't just have to fall back on a table. So yes, a table is good, but that doesn't mean that there aren't still things that you should be able to do without a table. That did not really help, did it? Identify graph clues. So some of the most basic graph clues are intercepts and symmetry. Good thing we talked about intercepts today in homework from section 1.1, because hopefully, if you guys just remember, oh, x-intercepts, that's right, hitting the x-axis. What did we already talk about? What's true when you're on the x-axis? The y's aren't up, the y's aren't down, the y's are... Sounds so easy. And solve. But sometimes the solving gets nasty, so I'm not saying it's always easy. There can be a lot of math that's involved. But basically, set y equal to 0. Solve y-intercepts, you're on the axis. The x's haven't gone positive or negative, so what are the x's? The only time these will be the exact same point is when the graph is going through 0, 0. Otherwise, you're looking for very separate points. We usually call the y-intercept B. And so, I don't know, just to keep up the pattern, we'll call the x-intercept A. But two separate points. When you're hitting the x, when you're hitting the y, the only time they can coincide is at the origin. So, the example down below should be super easy as long as you just think about, oh, where it hits the intercept, intersect, where it hits the, and you have a picture. It's easy. What's the x-intercept? Or seps? Yeah, -2 is going to be 1. What else? 0, 0. And 2, 0. What's the y-intercept? Crosses the 0. Crosses the x-axis. Each of those. You could have also said an alternate way of saying the x-intercepts are -2, 0, and 2. That works as well. Or you could actually give the points themselves. But here's the dealio. Yes, you should have been able to look at the graph. But my question is, how could you have done that from the equation? Let me scroll down. What if the graph wasn't there? What would you have had to do algebraically? Algebraically means looking at the equation, not looking at the graph. The graph is graphically. How could you? We're going to set y equal to 0, right? Some of you guys would have solved this, would have added the 4x divided by plus. You would have gotten the plus or minus 2, but you wouldn't have gotten the 0 if you had started adding right away. Does anyone remember the proper way to start this problem? It's not adding. It's not subtracting or adding. Good. Now, I wouldn't say take it away, but let me just change, like, as far as the English, I would say factor out. But yeah, you're right. Good, Jason. Factor out. Whenever you're setting y equal to 0, whenever you're trying to solve for zeros. Ooh, graphing calculator, second trace. Whenever you're solving for zeros, always, 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 what?
Factor.
Factor. Because then you can find all of them, because you would have your, when you set each of them equal to 0, just quick reminders from algebra, that would be your positive 2, that would be your negative 2, and this one would be your 0. Check, check, check. Does that make sense? The y-intercepts are super nice and easy. Just plug in x as 0 and solve. But just want to do a couple reminders as far as factoring. Always factor when possible, but only when one side is 0. Never when it has a number. Symmetry. Right. He's the main reason that this section of notes, well, logistics and symmetry. We had to go through quite a few logistics in class today. But symmetry is another reason why this homework is not due tomorrow. Not that it's impossible, it's just not your favorite. And some of you guys don't remember, symmetry also has to do with the idea of even and odd functions. Symmetry also has to do with the idea of even and odd functions. You guys can go ahead and skip. One line should be enough. If you want to skip 2 lines, I think we could probably fill it. But 1 line should be enough in between. I'll let you guys go ahead and get that set up. What's an animal that has symmetry? Starfish, yeah. Roughly, but yeah. I guess in nature everything's kind of rough, like it's not necessarily perfect, but in some ways. Zebra, it's true. I guess that's true. There you go. The normal example would be a butterfly, but zebra works. I don't really want to go cutting one in half, though. Okay, so butterfly. Let's go back to that, because that's easy, because they just already do that. Okay, symmetry. If there's x-axis symmetry, I think I actually already have graphs. Do I already have graphs? Yeah. Let me show you some examples real quick. X-axis symmetry, what is above is also below. There's a branch above, and there's a branch below, and they mimic each other. Which means that the horizontal and vertical distances to each section or to each corresponding point, the distances match, just the signs don't. Let me write it a little bit bigger. You have a point x, y, where you go to the right and up. You're going to go the exact same distance, but now to the right and down. So you're also going to have the corresponding point x and negative y. And that's where this hint comes in. So if you have an xy, if you go over and up, you're also going to go over and down. Y-axis super similar, except instead of up, now you're going to go back and up, which is why you have both of these 2 points, both the positive. As long as, like number 58 homework last night, they defined, like they showed the x had to be a negative number. Otherwise, we just kind of assume he's a positive. So you're going to have whatever's in the, or on the right of the y-axis also mimicking on the left. If you were to fold the y-axis, they would copy each other. They'd be on top. They would perfectly correspond. Then origin symmetry. This one's the weird one. So it does a little bit of, it's kind of like x and y together. Not that it has x and y-axis symmetry, but you have to think about going, whatever's in the first quadrant will copy over transformations in a sense. So if you have the positive x, positive y, you also have a negative x, negative y. Now, if it's a graph, it should be, hopefully, once you just remember what the terms are, it should be pretty easy. Like, oh, it's flipping over the x. Oh, it's flipping over the y. Oh, it's flipping over the origin. It's kind of this weird little, like, kind of going on, where you could think like that. If you have a graph, hopefully it's not too bad. But if you have equations, this is what you're going to want to do. You're going to want to take these different variations And in order to test for symmetry, symmetry is the big topic, but to test for symmetry, you're going to want to plug in I'll call them the corresponding points. And what I'm talking about is x-axis symmetry. There's going to be a corresponding point that's also true, and that's this one I underlined. For y-axis symmetry, the corresponding point is going to have this pattern. And for origin symmetry, the corresponding point is going to have that pattern. So what you're going to do is you're going to plug in the corresponding points and simplify. To test for x-axis, plug in the corresponding point and simplify. To test for y-axis, plug in the corresponding point and simplify. To test for origin symmetry, plug in the corresponding point and simplify. But you can't just plug in and simplify. Like, if that was all it was, it's like, sweet, they'll always have all three, and that's not true. This is just how to start. So step number 1, plug in and simplify. Step number 2, the symmetry works if it simplifies to be the same. And on that, you guys can go. The symmetry works if it simplifies to be the same. We'll talk more about symmetry tomorrow for sure, and do some examples. But you guys can work on homework up until, start on homework up until, I would say, symmetry. Bye, cool kids. See you tomorrow.
Cool kid.
Enjoy that A-push test.
I'll try.